My name's Alan. I'm at the Heriot-Watt University in Edinburgh. I'm currently in Glasgow. And I'm going to talk about some work in XAIP, Explainable Planning. And the idea in explainable planning is kind of around creating explanations of the planning process and its related aspects, which can require a lot of content, a lot of effort to kind of work out what suitable explanations are. And the idea in this work is that there's a lot of shared structure between planning problems, and it could be exploited in order to reduce the amount of content needing generated for each domain. So here's two examples. Explanations. So in a robot domain, Robbie cannot reach its goal location from its initial location. There is no traversable path for Robbie between these locations. And in a truck domain, there is no path between some location S0 and location S2. And so the idea is that computationally what we're looking at here is reachability analysis that's been performed, and the explanation could be based on some shared template between these two examples. And the kind of motivation is then that if we use generic problem structures and attach these explanations onto those instead, then that can happen. That sharing can happen. Okay, so what are generic problem structures? So this is going back to work from Maria and Derek, 2002. Planning with generic types is one of the outputs from this. And the idea was that lots of problems in the planning benchmarks, I guess, but also just in planning kind of scenarios, share structures such as transportation and manipulation. And if you write a solution for at the right level, or if you can write a solution at the right level, then when you come to a domain that kind of exhibits these kind of structures, then you can use the solution. Okay, so let's just have a quick look. So on the left we've got a transportation problem. We've got some trucks, some packages and locations. The domain analysis is then kind of looking at each truck and saying, oh, they can only be located at one location. They're always located at one location. And so you get this singleton kind of state machine. With packages, you have these structures where you can transfer between being in a truck to at a location, and together this is the kind of characterizing, they called it a fingerprint for what it means to be a transportation GPS, and they looked at a lot more generic kind of ways to define these things, so for example drivers and keys and other kind of relationships that exist. Okay, so an explanation system then would have this kind of component where you analyze the domain, you select which of these structures exist, and then they can be used, and anything that you've defined for them can be used when you're doing your explanation system-y stuff, like for example query interpretation or explanation construction. Okay, so for query interpretation, one of the things that you can kind of define is concepts, right? So you have your domain level concepts, for move, for example, and on top of that you can then, for example, in a traverser, so on this left hand side, a traverser domain, you might want to define things like the positions, the movers, where they're currently located, for example, and some additional concepts like route, reachable locations, for example. So we look at some example queries. You might ask, why did you go through L3 en route from L1 to L2 and not to L4? Why is package P1 allocated to truck 1 and not truck 2? So these are kind of reasonable queries, but they kind of have these fairly complicated concepts. So for example, if you're just trying to do a mapping onto the domain, these things aren't trivial. And so in the transportation kind of structure, these concepts have already been defined. So resource allocation and the kind of related concepts about picking things up and dropping them off, for example. Route distribution hub, so reallocating packages. And so in the example of this top query, why did you go through blah blah blah, with the right concepts, and could be written in a fairly simple template, why path option and not position, right? Okay. Okay, so returning to this transportation scenario, and a query like, why does the plan contain action load truck P1 T2A rather than action load truck P1 T1A? And this was an example from last year's XAIP, in the kind of planning as a service, XAIP, planning as a service. And in that case, it was basically what you're trying to do is add some constraints into your domain and then replan, and that gives you a kind of way to answer the query. So they were adding constraints like force load truck P1 T1A and prevent load truck P1 T2A. So from a generic problem structure point of view, you could tell that it was a resource allocation query, or at least that it could be, in the sense because the actions are related to that kind of problem. And so you might look at other ways of considering the query, and these could be used in different ways. So in terms of adding constraints, they can be used to constrain very tightly that all other, for example, allocations are exactly as they were in the original plan, and you only change the one that's being queried about. Okay, and just to give an example of what happens at the output side, right? So you can imagine in a traversal problem, you might have templates such as the one on the top right here, the location that mover can traverse, move action from it, and these kind of placeholders are then kind of fitted in with the actual problem information. So in this case here, we've got a robot, and he can't move to his goal. So the instantiated template then becomes the location that Robbie can traverse, move. So Robbie here has been just injected from the problem object, and move is the domain action name. From its current position are illustrated in the diagram below. So here we've got green is the initial position of Robbie, and red is the goal, and the reachable locations are in yellow. And so you can kind of clearly see why they can't reach their goal. And of course that's just an example, but the idea is that that example is written at the generic problem level and then instantiated for a specific domain. Okay, so planning problems often share generic problem structures, and they can be exploited in the context of explanation systems. And you can express your solution, whatever component we're talking about, at the kind of generic level, and then actually when you get an specific domain, you can instantiate it, and it allows sharing of content. Hopefully I am around if you have any questions, Thanks for listening.